Hello students, in this video we are going to discuss FSK, that is frequency shift keying. This is very simple and low performance type of digital modulation, right? So FSK is almost similar to the FM, but only the difference is the carrier of analog signal varies in accordance with the digital input signal. It's called FSK. We can also call that one as a binary frequency shift keying, right? So this is my carrier signal, right? This is my analog signal. The frequency of the carrier signal is vary in accordance with the digital input signal. Is called binary frequency shift keying or frequency shift keying. This is my modulated output, right? So we will discuss one by one how we are getting that FSK modulated signal. So this is my mathematical representation of FSK signal. So VC is my carrier voltage, cos this is a cosine function, omega CT. Omega C is a angular carrier frequency, right? We are representing with respect to the frequency 2 pi FCT. FC is my center frequency. This center frequency we are going to shift plus delta F minus delta F. Here delta F is a frequency deviation. See, the plus delta F minus delta F is determined by this modulating voltage. This is my carrier frequency, right? If it is logic 1 means my input signal is logic 1 means my Vm of t is plus 1 volt. My input signal is digital signal is or digital input signal is 0 means my Vm of t voltage level is minus 1 volt. So we are substituting these two equations in equation 1, right? So first we will substitute the equation 2. So whenever your input logic 1, so your Vm of t is plus 1 volt. So if you are, instead of Vm of t, if you are substituting 1 volt means you will get Fc plus delta F. Similarly for logic 0, Vm of t is minus 1. So you have to substitute this minus 1 in the equation 1. You will get Fc minus delta F. So your input signal is logic 0 means your frequency shifting is Fc minus delta F. Logic 1 means Fc plus delta F, right? So here we call this one as a mark frequency. Fc plus delta F is a mark frequency and Fc minus delta F is a space frequency. The mark frequency is you are getting at the logic 1. This is your mark frequency. The space frequency you will get at binary input of logic 0. In the mark frequency, the carrier signal is in the form of compressed wave. In the space frequency, the carrier signal is in the expanded format, right? So by using these two, Fc plus mark frequency and space frequency, we can able to find out the frequency deviation, delta F. So it is a modulus of mark frequency minus or subtract with the space frequency divided by 2. So by using this equation, we can able to find out the frequency deviation. This is our modulus of Fm minus Fs divided by 2. So here, so we can understand the concept by using this frequency domain, right? Frequency domain of FSK, right? So it is as shown in figure. So Fc is the center frequency. The center frequency is shift towards right and left. If it is the frequency is shifted plus delta F means this is a mark frequency. The center frequency is shifted minus delta F means that is a space frequency, right? So that one only we have represented as a figure. This is my mark frequency, that is my center frequency. My carrier frequency is shifted plus delta F. So here this is a space frequency, my center frequency or carrier frequency shifted minus delta F. So this is the overall concept of um, FSK modulated signal, right? So in the FSK modulated signal, we need to find out the bit rate and baud rate. It is and also bandwidth. Here the bit rate is as same as baud rate. So bit rate is a bits per second, and the baud rate is the unit of baud rate is symbol per second or baud per second, right? So the rate of change of uh, input signal of modulator is called the bit rate, or the number of bits per second is called the bit rate. Baud rate means the rate of change of output of the modulation is called the baud rate, right? Or the number of symbols obtained per second is called the baud rate, right? See here, this is my bit TB, right? So bit duration, right? Only one bit for the one per second, right? This is my signaling time, right? So TB TS that remains the same, right? TB and TS is remains the same with the same period and also with the same rate we are getting the mark frequency, so modulated output. So that's why the bit rate and baud rate remains the same. So baud is equal to FB divided by N, right? FB is my channel capacity, or we can also call that minimum Nyquist frequency or bandwidth. FB divided by 1. N is the number of encoded bits per signaling element. Here I have taken N is equal to 1. So the here but the baud is also equal to FB. Right? Here we need to find out the bandwidth of FSK. So this is the first equation. Bandwidth is equal to modulus of Fs plus Fb, right? Minus, this is Fs means signaling frequency, Fb means bit frequency. Fs plus Fb minus Fm minus um, Fs, the mark frequency minus space frequency. So uh, by using this equation, if we are modify this equation, so we will get Fs minus Fm plus 2Fb, right? Here Fs minus Fm is what? Fs minus Fm is 2 delta F. What is Fs? Fc plus delta F. Sorry, Fc minus delta F. You can also write here, I have written like a mark frequency minus space frequency. So here we have written in the form of modulus. Even if you are getting the negative value, so my result is always positive. That's why here we have written Fs minus Fm. Originally Ff minus Fs. So Fm means Fc plus delta F. Fs means Fc minus delta F. Mark frequency is Fc plus delta F. Space frequency is Fc minus delta F. If we are reducing this equation, we will get 2 delta F. So 2 delta F plus 2B. So we can written as 2 is a common factor. I have taken outside. So delta F plus FB. This is my bandwidth. So B is equal to 2 times of delta F plus FB. I hope you are able to understand this concept. Thank you.